Okay, let's dive right into this explainer by confronting a geographic reality that is, frankly, staggering. Imagine trying to sustain a massive, rapidly growing population of 37 million people in a country practically swallowed by sand. I mean, over 95% of Saudi Arabia's landmass is just unforgiving desert. That leaves an incredibly narrow margin, just 5% of non-desert land to actually work with. It's an environment where mere survival is pushed to its absolute limits.
And you know, this perfectly sets up the ultimate paradox of Saudi Arabia. On the one hand, you have immense world-coveted wealth sitting right beneath the soil, over 40 trillion liters of oil reserves. But on the other, an existential threat sitting right above it. The average annual rainfall is a meager, barely there trickle of below 100 millimeters. So you have endless oceans of oil, but practically zero fresh water. And, well, you can't drink oil. So how do you keep millions of people alive?
To solve this seemingly impossible equation, the nation had to dream up and then actually execute a multi-stage engineering miracle. We're talking about an invisible river of steel. It is a colossal, nation-spanning mega-project designed to actively pump billions of liters of seawater inland from the Red Sea straight across the barren desert.
Here is the blueprint for our explainer today. We'll start with a nation without water, then move into forging the Steel River. Next up is conquering the desert terrain, followed by the desalination miracle, and we'll wrap up with the ultimate cost. Section 1. A nation without water. The existential threat of geography. So geography really dictates the entire strategy here. You've got a population of over 37 million people, mostly densely concentrated on the coasts. Now add in summer temperatures that regularly exceed a blistering 45 degrees Celsius. In these kinds of extreme conditions, water is constantly drawn from the body, and yet fresh surface water sources are practically non-existent. There are no great rivers to tap into here. They had absolutely no choice but to turn to a vast, inexhaustible but completely undrinkable source, the ocean. The only solution was to build a nationwide water pipeline network originating right at the Red Sea.
Section 2. Forging the Steel River. Building the mega pipe.
The brute force industrial process required to actually manufacture the literal backbone of this project is just fascinating. We're talking about massive 1.8-meter diameter high-strength carbon steel pipes. They start out by cutting these thick rectangular steel plates, nearly 25 millimeters thick. Then they use a massive multi-axis rolling machine to literally bend the steel step by step until the edges finally meet. Next comes the longitudinal welding of the seam, which is immediately followed by straight flow water cooling to bring down the intense heat of the weld. Finally, they meticulously grind the edges for absolute geometric accuracy and finish with beveled edge welds so these massive cylinders can lock together perfectly. All of this is absolutely crucial so the pipes can withstand the extreme thermal cycles of the desert and continuous pumping pressure without failing.
Section 3. Conquering the desert terrain. Trenching through sand and rock.
All right, with our 12 to 18-meter pipe sections forged in the factory, we enter an absolute logistical nightmare, laying thousands of kilometers of steel across completely unforgiving sand and rock. And the financial reality of this? It's staggering. $3 million. That is the average cost to lay just one single kilometer of this pipeline through the harsh desert. And remember, that exorbitant price tag doesn't even include the massive booster pumping stations required to push all that heavy water uphill or the desalination plants themselves. We are looking at an astronomical national investment just to move the water from point A to point B.
To justify that kind of wild expense, efficiency is literally everything. To maintain a relentless driving pace of 1.5 kilometers per day, they have to run a super tight ship with a highly synchronized workflow. Weeks in advance, GPS surveying teams map the route and clear a 40-meter wide corridor. Then, day one involves mechanical excavation, and if they hit mountains, they bring out controlled explosive rock blasting to shatter the bedrock. Day 2 is all about leveling a fine sand bedding so the pipe rests evenly and stress-free. Day 3 brings in the automated welding teams, knocking out an incredible 150 joints a day using specialized machines. And Day 4 wraps it all up with multi-layer backfilling and mechanical compaction, so the shifting desert sands don't destroy the pipe's alignment over time.
And here's where it gets crazy delicate. After the pipeline is welded and coated in a protective liquid epoxy, you literally cannot drag it. A single scratch could lead to corrosion. So multiple side crane tractors use padded slings to lift a massive, continuous string of steel. They have to perfectly coordinate to lower this immense weight centimeter by centimeter while it's suspended in the air. The goal is to set it onto the sand bedding without ever touching the abrasive trench walls, ensuring absolutely zero residual stress or damage to the pipe.
Section 4. The Desalination Miracle, stripping salt from the sea.
Okay, so the pipeline is built, the infrastructure is there, but pumping 3.5% salty seawater inland is completely useless for drinking, farming, or industry. Before we even think about touching the salt, we have to meticulously strip the water of literally everything else. It starts out at the deep sea intake, where 63-centimeter pipes pull in 15 million liters of water every single day. First, massive screens physically block uninvited guests, jellyfish, crabs, and any debris larger than 4.5 millimeters. Then, gravity sand filtration traps suspended sediment. Next up, they inject chemicals like ferric chloride, which acts as a coagulant, causing the ultrafine waste to clump up and drop out. Finally, the water is pushed through cartridge filters made of tightly compressed fiber layers. This traps microscopic particles as small as 1 to 5 microns, which is, to put it in perspective, roughly 1/10 the thickness of a human hair.
Now the water is totally clear, but obviously it's still completely salty. And because salt ions cling incredibly tightly to water molecules through electrostatic attraction, traditional filtering just won't work. We have to rely on a magical brute force scientific process called reverse osmosis. This means applying external pressure that is vastly greater than the water's natural osmotic pressure. We literally force the water through an ultrafine membrane, leaving the stubborn salt and impurities trapped on the other side.
But to break those molecular bonds, you need some serious power. High-powered centrifugal pumps pressurize the seawater to an astounding 60 bar as it hits that reverse osmosis membrane. Think about that for a second. That is roughly 60 times normal atmospheric pressure. It's just an unfathomable amount of force, squeezing the fresh water right out of the salt's tight grip.
After that brutal first high-pressure stage, the water is mostly fresh, but it still has trace ions. So it actually goes through a second reverse osmosis stage at a lower pressure, using even finer membranes to completely strip it down to pure electrical conductivity. But here's the catch. Pure, perfectly purified water isn't great for drinking. It has the wrong pH and tastes totally flat. To fix this, they adjust the pH with balancing solutions. And finally, they actively remineralize it, intentionally infusing it back with essential calcium and magnesium so it actually tastes good, has a natural profile, and keeps the population healthy.
Section 5. The ultimate cost. The high price of survival.
Saudi Arabia has essentially transformed the ocean into a lifesaver. But this engineering triumph carries a remarkably heavy toll. Creating this artificial oasis, running those giant intake pumps, pushing water through membranes at 60 bar and pumping it hundreds of kilometers across a sweltering desert, it costs roughly $5 for every single cubic meter of water delivered to residential areas. When you juxtapose Saudi Arabia's $5 per cubic meter cost against the cost in countries like the United States, where water is often naturally abundant and costs merely a few tens of cents per cubic meter, you really start to grasp the immense economic weight of surviving in the desert. They're paying an absolute premium just to ensure basic human survival. And that leaves us with a pretty profound question to take away from this explainer today. As global temperatures continue to rise worldwide and easily accessible fresh water vanishes in more and more regions, is Saudi Arabia's incredibly expensive, engineered, invisible river of steel the inevitable future for the rest of the world? What seems like an extreme, highly localized miracle today might just be the baseline survival blueprint we all need tomorrow. Thanks for joining me on this deep dive, and keep questioning the world around you.